This video is for example 1b. Do these results suggest that such support groups could be an effective way to help people stop smoking? And I'll keep the problem down here for a moment. So, as we do this, we want to set our null hypothesis. So we had two groups. One was, the problem refers to them as group 1, patch and meet, and group 2, patch only. So P group 1 equals P group 2. And so that would be saying there is no difference in effectiveness between the patch plus meetings and patch only treatments. So now they're looking to see, they believe that the proportion of people who stop smoking in group 1 is going to be greater than, so that would be patch plus meeting is greater than proportion with group 2. Take note really quick, the hypotheses same on the right and on the left, equality in the null hypothesis and a greater than for the alternate. Now before I do the checks, I do have to show some calculations. The first is p hat for group 1, and I want to show this. This is 46 out of 143, which is 0.322. P hat group 2 is 30 out of 151. So that's 0.199. And then lastly, I have to do the combined proportion, because the null hypothesis is assuming for the populations these are the same. So these are both estimates of this unknown combined proportion. And I just use p hat. And to do that, you'll do successes in group 1 plus, so that's a 46, plus successes in group 2 over sample size group 1 plus sample size group 2. And 46 plus 30 divided by 143 plus 151. So this equals 0.259. This one's going to become important because we're going to use it for our checks. So the first check, and this is a long problem now. The first check is, are these two groups independent? So do we have independent populations? So independent groups. And the answer to that is yes, the groups are independent. So then the remaining checks for each group, and I will usually make one of these tables. So for group 1, I'll check all 3 checks. For group 2, I'll do all 3 checks. So the checks are randomness, independence, or independence, and our normality check. So for randomness and independence for group 1 and group 2, this is a well-designed experiment. So I'm just going to write randomized experiment over all of that. So I've done all 4 of those checks now. Now for the normality check, I'm actually going to use p hat, not p hat group 1 or p hat group 2. I'm going to use the combined proportion. So this is where the sample sizes become important though. So I'm going to do 143 times 0.259. Is that greater than or equal to 10? It is. And 143 times, now 1 minus 0.259 is about 0.741. Is that greater than or equal to 10? It is. And now I'm going to do both of these checks again, but now using 151. 151 times 0.259. Is that greater than or equal to 10? Yes, it is. And 143 times 0.741. Is that greater than or equal to 10? Yes, and it is. So now I have done hypotheses, I've done the checks. So now I'm going to perform the actual test, and I'm going to turn to my calculator here. So let me just get it so you can see it. So I'm going to go to Stat, Tests, and I want 2 prop z test, 6. So x1, this is where having these proportions is going to become important for us. 46 over 143. 30 over 151. Now my alternate was a greater than. And I like to go to draw, but I'm going to go to calculate because this is going to have some more information. So I need the test statistic. And it is listed right here. That is the z. So I'm going to kind of put it to the side for a moment. Test statistic. So my test statistic is 2.4077. My p-value is 0.0080. Now, p hat 1 and p hat 2, these are nice ways to check. Did we do calculations correctly? P hat 1, that is what I got. P hat 2, that is what I got. And then p hat here is the combined proportion. This is a really important one to check, and that is what I got. So now I'm going to make a decision and draw a conclusion, and I will say, after I finish drawing a conclusion, I'm going to show I'll decide on whether or not I want to show the calculation of the test statistic. It's kind of an annoying process. But, so, since my p-value was less than 0.05, and that was our alpha here, I reject my null. Semicolon. I have statistically significant evidence that the proportion of people who do the patch plus meetings and quit smoking, it's probably not worded the best, but is greater than, so this is the alternate in words now, is greater than people who only use the patch. Really quick comment. I honestly feel I could word that better. However, reasonable and in context, I believe this would count as reasonable and within context. So I did mention I'd show the test statistic, and if you want to see it calculated, let me show the calculation of the test statistic really quick. So it's always going to be the difference in the two proportions So this is going to be 0.322 minus 0.199 minus the actual difference claimed by the null, in this case 0. You usually won't see that. Over the square root of, we're going to make use of p hat now, 0.259 times 1 minus 0.259, which was 0.741, over 143, that's the sample size of the first group, plus these same two, 0.259, the combined proportion, and 1 minus the combined proportion, all over 151, which was the sample size of the second group. And if I do this on my calculator, I should be getting 2.4077, or awfully close. So I'm going to do 0.322 minus 0.199, and I am going to remember that I have rounded here. 0.259 times 0.741 divided by 143 plus 0.259 times 0.741 divided by 151. Your calculator did not round, but the test statistic should be remarkably close. So we're getting 2.4062. So the difference begins in the third decimal place. I rounded to the third decimal place, so I'm not really too shocked here. So that is how you do a hypothesis test for a difference of two proportions.